So in this problem, we will evaluate some probabilities of normal distribution curve with the help of normal distribution tables. First problem is find the probability values that z greater than or equals to 0.85. Here the sign is also important. It is a plus 0.85. So if it is a plus 0.85, if you look at the normal distribution curve, central line z is equals to 0 and we have a plus 0.85, so it will lies right to this z is equals to 0. I am indicating it 0.85 somewhere, let it be here. Now z greater than or equals to 8.5 means z greater than or equals to 0.85 means z values which are above 0.85. So towards the right side we will have values which are more than 0.85. So clearly this is the area required, which is above this point that is equals to 0.85. Now from the normal distribution table we will always get the area from 0 to some particular point z, but this is started at z is equals to 0.85. So this a small area, how do you get it from the property of the normal distribution? We know area left to 0 up to plus infinity, this complete area is half, that is 0.5. Even left to 0 to minus infinity is also 0.5. So total z is equals to 0 to the end is 0.5. We want only a portion of that, that is this part, this portion. That means if you are able to remove this, if you are able to remove this portion from total, remove from total area, then we'll get the required area. That's what the logic. To get this from the total area, remove this. So that, so let me take another graph. See, I want the area which is in red color. So I want the area in red color. The total z is equals to 0 to plus infinity area is 0.5. So if I'm able to get this area from 0 to 0.85, so that I'll remove from 0.5, I'll get the required area which is greater than 0.85. So to get area from 0 to 0.85, you can use a normal distribution table. To see the normal distribution table, 0.8 is value, it is intersection of 0.8 and 0.05. When you combine 0.8 and 0.05, when you add 0.8 and 0.805, you get 0.85. That means intersection value, this is a required area value, which is 0.3023. So this value I got it as, this area value I got it as area value of this black color shaded portion, 0.3023. Now I want this red color portion area, that is our expectation. Total is 0.5. So what I will do, I will remove this 0.3023 from the total 0.5. I'll get the required portion area as 0.1977. This is the way how we can calculate the areas. Next question, probability that z less than or equals to minus 2.43. So z less than or equals to minus 2.43, it's the left side to z is equals to 0 because it is a negative number, so it will be left to z is equals to 0. And it can be written in the same way, minus 2.43 area from z is left to minus 2.43 is the same as of right to 2.43. So instead of minus 2.43, if you write it on the right side of z is equals to 0, write it to plus 2.43. Now I want the area which is in green color shaded portion, this one. So to get this, what I'll do, I know right side complete area from z is equals to 0 to z is equals to plus infinity, this complete area we know which is 0.5. So total area left to z is equals to 0 is right to z is equals to 0 is 0.5, and this area we have to calculate. If you know this portion, then just if you subtract this portion from the total area, you will get the required areas. Okay, so how do you get this z is equals to 0 to 2.43 area? So you can use the normal distribution table to get 2.43. 2.43, let me take it, it is, yeah, 2.4, and column wise I have to see 0.03. Let me take it as, let's see, this is a column, and 2.43, 0.4 and 3, it is 0.4925. This is the value, so 4925, 2.43, so that this area value, I'm getting as 0.4925. Now how do you get this shaded portion area? By removing this 0.4925 from the total area 0.5, that is 0.5 minus 0.4925, so that we get the answer as 0.0075. This is the same as of z less than or equals to minus 2.43. The next third question, area in between minus 1.642 minus 0.88, minus 1.64 to minus 0.88. If you draw the normal curve for this, let me take the normal curve. This is z is equals to 0, and the minus 1.64 minus 0.88. So let me take this as minus 0.88. Obviously minus 1.64 will be left to this, not right side, left to this. Let me take somewhere here minus 1.64. so in between these two lines area expected in this problem. So we calculate this area. We know complete left to this is, but the both points are in between. So what we'll do, we'll calculate area between 0 to 1.64. Okay, can get it from 0 to 1.64 from the table. Again, area from 0 to 0.88, this also will get it from normal distribution table. Then removing this area from this area, I mean green color area, I mean 0 to 1.64, so that will get required area. So what we are going to do is we have to remove area from 0 to 1.64 minus area from 0 to 0.88. So when you subtract this, we get the required portion. How do you get the area of 0 to 1.64 area? You go to the normal distribution table and 0 to 1.64 area, 1.6 it is, and 4, 0.04 is this one, this column. So 0.4495. Similarly, other value also you can calculate. So area from 0 to 1.64, we got this value as, in the normal distribution table, 0.4495, and this value we got it as 0.3106 from the normal distribution table again. When you subtract these two, 0.4495 minus 3106. You get this black color shaded area, that you will get it as 0.1389. This is how we calculate the area. And the last problem, look at the last problem. Z less than or equals to 1.94. This you can write it as Z in between plus 1.94 to minus 1.94. So if you look at the normal distribution curve for this problem, comes like plus 1.94, write it z is equals to 0, plus 1.94, and minus 1.94 left to z is equals to 0. We are expecting area between these minus 1.94 to plus 1.94. This complete area we are expecting. So what you can do, from the normal distribution table you will get it from 0 to 1.94 area from 0 to 1.94. you will get it from normal distribution table, and even other side is also same, minus 9.4. this area will be same. So you can do area from so and so 2 times you can add it, or plus area from minus 1.94 to 0, both will be same only. So how do you get this area from the normal distribution table? 1.94. 1.94 area is 0.4738. This area is 0.4738. You can check it with the normal distribution table, and these two areas will be equal because the same ordinate 1.94. So this is also 0.4738. Then the total area requires this and this total area. When you add these two numbers, it is 0.4738 plus 0.4738, you will get the required area, which is 0.9476.